Hi, I'm Neil Rhodes. Welcome to the Divide and Conquer module. In the last module, you learned about how to use greedy algorithms to solve particular classes of problems. In this module, you'll learn about ways of solving problems using divide and conquer algorithms. The term divide and conquer is quite old, and when applied to war, suggests that it's easier to defeat several smaller groups of opponents than to try and defeat one large group. In a similar fashion, divide and conquer algorithms take advantage of breaking a problem down into one or more subproblems that can then be solved independently. Just as not all problems can be solved with a greedy algorithm, not all problems can be solved using divide and conquer. Instead, these are both techniques that are part of a toolbox of strategies to solve problems. As you're designing an algorithm, you'll need to consider whether or not a greedy algorithm might work. If not, would a divide and conquer algorithm work? Let's look at the general structure of a divide and conquer algorithm. Here we have a problem to be solved, represented abstractly as a blue rectangle. We break the problem down into a set of non-overlapping subproblems, represented here by colored rectangles. It's important that these subproblems be of the same type as the original. For example, here's a way to break down the original rectangle problem into a set of subproblems that are not of the same type. These subproblems are triangles. Thus, this does not represent a divide and conquer algorithm. In this case, we've broken down the original rectangle problem into a set of subproblems that are themselves rectangles. The difficulty is that these subproblems overlap with one another. Thus, it too does not represent a divide and conquer algorithm. We return now to breaking down our problem into a set of non-overlapping subproblems of the same original type. We break it apart. Then we go ahead and solve each subproblem independently. We solve the first problem, represented by a check mark. We then continue, solving each problem in turn. Once we've successfully solved each of the subproblems, we combine the results into a solution to the original problem. One question that comes up: how do we solve each subproblem? Since each subproblem is of the same type as the original, we can recursively solve the subproblem using the same divide and conquer strategy. Thus, divide and conquer algorithms naturally lead to a recursive solution. In practice, while you can program a divide and conquer algorithm recursively, it's not uncommon to rewrite the recursive program into an iterative one. This is often done, both because some programmers aren't as comfortable with recursion as they are with iteration, as well as because of the additional space that a recursive implementation may take in terms of additional stack space. This can be language and implementation dependent. In summary, the divide and conquer algorithm consists of 1. Breaking a problem into non-overlapping subproblems of the same type, 2. Recursively solving those subproblems, and 3. Combining the results. In the next video, we'll see an extremely simple example of divide and conquer.